Today's lecture, Lecture 3, is going to be on trade discount. So this is another new word. When we're talking about trade discounts, we're talking really about wholesale or bulk orders of a product and the discount that a retailer gets on ordering lots of stuff. So in this image here, we can see that we have a retailer acquiring a good for $70 and then selling it to the customer for $100. Now the focus of lecture 2 was on how we went from $70 to $100. But today what we're focusing on is this retailer and how they got the good for $70 to begin with. Let's say this is something like a sneaker that they acquired from a company like Nike or New Balance or something. How did they get this at such a low price compared to what the final customer can expect? And that is through what we call trade discounts. The thing is that this retailer isn't just buying one sneaker. They're not even buying 10 sneakers. They're going to buy a bulk order of sneakers, usually in the hundreds or thousands quantities. And therefore, the company like Nike or New Balance, whatever that sneaker company might be, would offer them a discount because they're buying so much of the product. And that is what we are going to be talking about today. This discount that the shoe company would be offering the retailer would be what we refer to as a trade discount. What we've worked on so far is that when we have a retailer, they have a cost, they mark it up to get to a selling price, and then they mark it down if they want to put it on sale. Now they don't have to do that, but if they choose to put it on sale, it's a markdown process from the regular price. And ultimately, we get to a customer's final price, typically with the addition of taxes. But how does the retailer get its cost to begin with? Well, they get a product from a manufacturer or supplier, or they produce it themselves. But today we're going to be talking about that transaction between an external manufacturer or supplier to the retailer. So this is when a retailer isn't making the good themselves and they're purchasing it from someone. How do they get a cost that is below the customer's final selling price? Well, it's with the idea of buying lots of an item. When you do that bulk order, a retailer is going to get a discount on a product. And the more a retailer orders, typically the larger the discount they get from the manufacturer or supplier. So that when we think about retailers like Amazon, they order so much of a product, they get giant discounts, which means that they can offer it later to a customer at a lower price. I'm going to introduce another new term here. It's called the list price. It's the amount the manufacturer or supplier believes the final customer will purchase their product for. Ultimately, it's a suggested retail price. To put this into context, I'm going to give an example. You own a bookstore and placed an order for Harry Potter and the Philosopher's Stone. So here's the book. What is the list price for this book? Well, I think we've all seen this before on books, where we turn around the book and on the back we see this code, and that list price is the price listed right there. It's $29.99 for this book. It was hardcover. So that's the suggested retail price. Of course, a retailer doesn't have to sell it for that price, but that's the suggested retail price that the publisher believes the book will sell for. So the manufacturer or the publisher of the Harry Potter book provides this to the retailer, a bookstore, and they have a list price, their suggested retail price to that retailer. Of course, they're not going to be selling it to the retailer at that list price. That list price is for the final customer. Instead, they charge the retailer that list price minus a trade discount. That's the rate at which the manufacturer reduces the list price of a product when it sells it to a retailer. So there's a reduction to the list price by that discount so that the retailer ultimately gets the book at a lower cost. And we do that calculation for the cost of that retailer as the list price times 1 minus the discount, a percent change. And we call that price the net price. So we have another new term here. Net price is the amount the manufacturer or supplier sells a product to the reseller for. Now, from the reseller's perspective or the retailer's perspective, it is the price that a reseller pays or a cost of merchandise. So now we can see here that cost ultimately becomes the net price, or that net price becomes the retailer's cost, I should say. So let's put this back to our Harry Potter book. You are purchasing 500 copies of the book from the publisher. The publisher agrees to give you a discount of 30%. What will the net price be? How much is the publisher going to charge you, the retailer, for each copy of Harry Potter? So using this relationship, I have the list price of $29.99 and the discount of 30%. So I have $29.99 times 1 minus the discount of 30%, and I have a net price of $20.99. So this amount here is how much it's going to cost the retailer or the bookstore for each copy of Harry Potter. Now you underestimated demand and want to increase your order to 5,000 books. So you're going up from 500 to 5,000. That's substantial. So the publisher says, okay, we can give you extra discounts if you're going to buy that much. So the publisher agrees to give you an additional discount of 15%. Now what will the net price be? So how do we do this calculation? Well, we have the net price after our first discount. They said they're going to give us an additional 15%. So I take that additional discount, that second trade discount is how we would refer to it, and I put that in as 1 minus 0.15, and I multiply that to the previous price, and I get $17.84 per copy. Now, we can rewrite this entire relationship as $29.99 times 1 minus 0.3. This is what got us that $20.99 to begin with, times 1 minus 0.15. Ultimately, we have this general form of the list price times 1 minus the first discount times 1 minus the second discount. And we can extend this formula to include any number of discounts. As they order more, they're going to get more and more discounts that get stacked on top of each other. So coming back to our example, we've established that as they order 5,000, they get 2 discounts, 30% and 15%, ultimately giving them a net price of $17.84. So now the next question is, what is the cost to the retailer for each book? Well, the cost for every retailer is the same as the net price. So the cost for the retailer is $17.84. So we use these two terms because from the wholesaler's perspective or the publisher's perspective, it's a net price of $17.84 per book. But from the retailer's perspective, that ultimately becomes their cost. So as you know, I have a love of flowcharts so that we can always sequence a problem. I want us to know that the manufacturer provides something to the retailer and that net price ultimately becomes the cost to the retailer. From there, we can do, like I said before, the markups, markdowns, etc. So I'm going to link that in right now and do a little bit of lecture 2 material. So what is the selling price for each book at the bookstore? So how much do they sell the book for? Well, we have a list price of $29.99. Now, does that have to be the selling price? Actually, it doesn't. It's a suggested retail price, but ultimately it's up to the retailer how much they charge for the book. They can sell it at any price they want. The list price is a suggested price, but retailers ultimately decide what to charge their customers. So we don't know what the selling price is yet. Okay, part F, you decide to sell the book at the list price of $29.99. Okay, so the retailer's decided $29.99 it is. What is your rate of markup? So let's recall that the manufacturer went to the retailer with the trade discounts. We got a cost or a net price of $17.84. Now we have our regular price, $29.99. So markup, the dollar amount markup, is going to be the $29.99 minus the $17.84, meaning $12.14 is how much you profit for each book sold. But this isn't asking for the dollar markup, it's asking us for the rate of markup. So the rate of markup is a ratio of markup to cost. So it's going to be 1214 divided by our cost of 1784, giving us 0.68067 as a percentage. That's 68.1% when rounded to one decimal. Now we could go further and talk about having a discount, adding in taxes and such, but that was all stuff we covered in lecture 2. I just wanted to demonstrate how this links into this flow chart over here. Ultimately, for this lecture, we want to talk about trade discounts, which is this formula highlighted in yellow right here, how we establish that net price from a list price and discounts that get chained. But once we establish that net price, it becomes the cost to the retailer, after which the markups and markdowns from lecture 2 would apply. So now that we have all that under our belt, we got some familiarity with trade discounts, let's try another example. Might be a little bit more complicated. Example 2, Ski West snowboards. So Ski West sells snowboards to retailers for $1,200 less discounts of 20% and 15%. We're going to calculate the retailer's cost. So remember, the retailer's cost when they get an item from a manufacturer is going to be our trade discount net price. Cost is the same as net price for the retailer. So now how do I figure out what this list price and discounts is based on this language? This language is a little bit weird at first, but this is typical language used by suppliers to retailers, where we would have a list price, in this case, $1,200, and then we would have the trade discounts that are being applied to it. 20% and 15% in this case are the two stacked discounts. So this 1,200 less discounts of 20% and 15% is very typical language that a wholesaler is going to use. The first amount, that 1,200, would be the list price, less discounts of, and then you get the trade discounts listed. Now let's plug this all into our formula. Of course, we don't have that third discount in this example, so I'm just going to X that. I'd get a net price of $1,200 times 1 minus 0.2 times 1 minus 0.15, which gives me $816 after I plug it into my calculator. Give it a whirl to make sure you can do it in your calculator. Okay, part B. This time we're asking how much is that second discount alone. And we want that value in dollars. Well, we knew that the net price was $816, but that was at the end of the second discount. What was it after the first discount? The net price after the first discount was $1,200 minus just that first discount of 20%, giving us $960. So our second discount in dollars is going to be the $960 minus the $816, giving us $144. Part C. What single discount rate is equivalent to the chained discount of 20% and 15%? So what is the overall discount if I were to apply just one number? What is the overall discount they're getting on these snowboards? Well, we know that the net price, that final cost, is $816 and that the list price is $1,200. So what discount? So what is the singular discount rate to go from $1,200 to $816? So there's two approaches we can take for this. First approach is to just calculate percent discount as the change in price divided by the old price. That would be the change in price from $1,200 to $816 divided by 1,200. That gives me $384 divided by 1,200. Ultimately 0.32 or 32%. So that's our general form for a percent change formula. It's going to be old minus new divided by old. The old is our list price. It is what the original price is. The new is after the discount. And make sure that in the denominator you put the old. That's a common mistake. It can't be the new because it is the old price that is being discounted. Now, I said that there were two approaches to doing this problem. Let's try the other approach. So this is just a repeat of the last slide, just to give space for the second approach. So approach 2, for our single discount rate, we know that net price is equal to list price times 1 minus the first discount times 1 minus the second discount, etc. Let's plug in those values into our formula. Now, if we had one equivalent discount, this is what it would look like instead. And you can see that I have made that equivalent to our natural approach of 1200 times 1 minus 0.2 times 1 minus 0.15. Now we're just going to do a little bit of algebra, and we can see that the 1200s cancel each other out. They're on each side. We divide both sides by 1200. They just cancel out. And I'm left with 1 minus the equivalent discount is going to be equal to 1 minus 0.2 times 1 minus 0.15. I can do the math on the right-hand side, and I get 0.68. And if I rearrange that, I get the equivalent discount is going to be 1 minus that 0.68, leaving me with 0.32 or 32%. So this is the formula that you're going to get on your formula sheet. It's 1 minus the equivalent discount is going to be equal to 1 minus the first discount times 1 minus the second discount, and you can add on any other subsequent discounts that may exist. Okay, part D. A retailer sells a Ski West snowboard for $1,020. Calculate their rate of markup and percent margin. So this question is asking for the rate of markup. Let's make sure that we're defining that correctly. That's the ratio of markup to cost, as well as it's asking for the percent margin, which is going to be our markup to selling price ratio. Now we are going to be selling these snowboards for $1,020. Note that this is below the list price, but we have that option of selling at any price we want. Now the cost is our net price, which we established in part A. Our net price is $816 after the two discounts of 20% and 15%. So I can calculate my dollar markup as the difference between the selling price and the cost to be $204. Now let's calculate our rate of markup that's associated with that. It's $204 profit or markup divided by $816 cost, giving me 0.25 or 25%. The percent margin is our markup divided by our selling price. So that is going to be our $204 markup divided by our selling price of $1,020, giving me 0.2 or 20%. Part E, another retailer maintains a 25% margin on all snowboards. You buy a snowboard from them during their 20% off end of season sale. How much did you pay after GST and PST? So this is another retailer that Ski West distributes their snowboards to. They're having a 25% margin on their snowboards, and then they're having a 20% off markdown. Let's assume that they have a similar supply to our previous retailer, and so they get the same trade discounts, so that their net price is $816. Now this question is asking, how much did you pay after GST and PST? Since we've already established the cost after trade discounts, we're in this portion of our flow chart. We've got the cost right here. So then we would have the markup happening, which is associated with our margin. So that's what we're going to work with to begin with. We're going to look at our 25% margin, or 0.25, and try to establish what that regular selling price is before we go about trying to do any further calculations. So what is that selling price? I go to my formulas and I can look for the relationships that I can calculate using cost and margin, because I have cost and I have margin. So I can see cost in the first formula, but I don't know what the markup is. I don't know what the selling price is. That's unsolvable at this point. I have margin in the second formula, but I don't know what the markup nor the selling price are. Again, unsolvable. This one right here, I've got cost, no markup, no rate of margin, not solvable. Let's look at this third equation. I've got cost, I've got margin, and I'm trying to solve what the selling price is. This is, in fact, the equation that will get me the selling price. So now using that equation, I have cost over 1 minus the margin. I plug in the values, so I get the $816 cost divided by 1 minus 0.25 margin, giving me a selling price of $1,088. I'm going to continue this problem on the next slide just for space. So I have my cost of $816 and my selling price of $1,088 established. So I can write that here. This is now $1,088. Now I can work with the markdown using our 20% off discount. So a sale price is going to be our regular price times 1 minus the markdown. Plugging in the values, I have my regular price of $1,088 times 1 minus the 0.2 or 20% markdown. That gives me a sale price of $870.40. Now the last part this question's asking is to include the GST and PST. So that's one more link in our flow chart. This is where taxes come in. So my final price is going to be $870.40, the sale price that we're working from, times 1 plus, because it's a tax increase, 0.12 for the 12% tax increase. This gives me $870.40 times 1.12 or $974.85. Onward to part F. Since it is near the end of ski season, Ski West wants to add a temporary third discount to bring the overall discount rate to 35.4%. What third discount rate is required? So Ski West wants an overall discount rate of 35.4% on their snowboards, and we're looking for an additional third discount rate to make that happen on top of our previous 20% and 15% trade discounts. So we know we have a list price of $1,200, giving us a net price after the first two discounts of $816. This was established after part A in the problem. Now a net price is this relationship that's just popped up at the bottom, and our desired net price now with a 35.4% discount is going to be a little bit different than what it was before. Our desired net price is going to be $1,200 times 1 minus the 0.354 overall discount that we want, meaning that we want, or Ski West wants, the net price to become $775.20. What we're looking for is what this third discount right here is going to be to make that happen. The first two discounts are remaining as is, so we need a third discount to make that happen. Well, how do we calculate a discount? We compare the before and after. So the dollar amount of discount is going to be the $816 after the second discount minus the $775.20, giving us $40.80. Now, we talked about percent change is going to be the old minus new divided by the old. For our third discount, that's going to be the $40.80 discount. That's the old $816 net price minus the new net price, divided by our old net price of $816. That old net price being after two discounts. That gives us 0.05 or 5%. So a third discount of 5% will bring our overall discount rate to 35.4%. Part G, a competitor has the same list price but offers discounts of 25% and 15%. What third discount rate should Ski West allow to match the competitor's price? So we're going to ignore part F, the previous part we just did, and instead we're going to talk about competing with another snowboarding manufacturer. So Ski West's discounts for 20% and 15%. This company has the same list price as Ski West, but their discounts are a little bit higher at 25% and 15%. So what third discount rate should Ski West allow to match the competitor's price? So a reminder that the list price for Ski West was $1,200, which will be the same as for the competitor. The competitor's net price, therefore, with their different discounts of 25% and 15%, is going to be $1,200, the list price, times 1 minus 0.25, or 25%, times 1 minus 0.15, or 15%, giving them a net price of $765. Now, Ski West, meanwhile, had a net price of $816. We're wondering what third discount is going to be required for their net price to go from $816 down to $765, the competitor's net price. So using our percent change formula, we're going to take the old minus the new, 816 minus 765, and divide it by the old net price of $816. So we can see in the numerator that this is the discounted amount that Ski West wants, 816 minus 765, or $51, and that our denominator is Ski West's current net price, which is going to be the old net price, of $816. That gives us 0.0625. Turning that into a percentage, I get 6.25%. And now we're into our last part of this question, part H. So I'm going to warn you, it's going to take 3 slides to complete as they're divided into 3 parts. So bear with me. Okay, part H. Another competitor sells snowboards for $1,100 less 20% and 10%. So this is a different competitor. We're going to ignore the last competitor. What third discount rate does Ski West need to match the competitor's price? So this new competitor has a list price of $1,100 less 20% and 10%, and we're looking for a third discount so that we can match the competitor's price. So I'm going to divide this into 2 sides. Now I'm going to look at our competitor, and then on the right hand side I'm going to look at Ski West later. So on our left hand side with the competitor, I've got a list price that's lower than Ski West's, $1,100, while they have the same discounts of 20% and 10% written as 0.2 and 0.1 respectively. So we're going to take our net price formula. Net price is going to be the list price of $1,100 times 1 minus the first discount, 0.2, times 1 minus the second discount, 0.1. That's going to give me $792. So how does Ski West match this? Well, first of all, where's Ski West at? So Ski West has a current net price after 2 discounts of $816. That's from part A of this question. So Ski West wants to have a percent change, a third discount, so that they can bring down their price to $792. So I'm going to use a percent change formula to determine that third discount. And that's going to be the change, the $816 going down to $792, divided by our old, or in this case, current net price of $816. That's going to give me 24 divided by 816, or 0.02941. Changing that to a percentage, I get 2.94%. So if Ski West applies a third discount of 2.94%, they will match this competitor's net price of $792. So the second part of this question, we have the same competitor. What third discount rate is needed so they can beat the competitor's net price by $27? So we want a third discount rate that's not only going to match the competitor's price, but beat or be lower than their net price by $27. So let's split this screen to be the competitors on the left and Ski West on the right again. We established in the previous part that the competitor's net price is $792. Ski West's net price before the third discount is $816. Now we want the desired price to not just be $792 as it was before, but we want it to be $27 lower. So that's going to bring us to a desired price of $765, not $792. This is going to be lower than the competitor's price so that they can beat them. So our percent change formula doesn't change. We're going to take that third discount to be the change from 816 to 765 this time though, not to 792. And our old price is still 816. That's going to give us a change of $51 this time, divided by $816 for a discount of 0.0625. Turning that into a percentage, I get 6.25% for the discount this time. Part 3, same competitor. Suppose Ski West wants to reduce the $1,200 list price instead of adding a third discount. So they're saying, let's scrap this third discount concept. Let's just lower our list price. What list price is required so they can beat the competitor's net price by $27? Our desired net price is $765. That's going to beat the competitor's net price by 27, which we established in part 2 of this question on the previous slide. So the idea now is to change the list price, not the discounts. So we're going to maintain our discounts of 20% and 15%. There will not be a third discount. But instead, we want to change the list price to be lower. So what list price is going to be required? Well, it's going to take a little bit of algebra. Let's plug in what we know into our net price formula. So the new net price we want is $765. So I'm going to plug that in, and we're just going to have the two discounts of 20% and 15%. Our list price is unknown. We have the list price times 0.8 times 0.85 is 765. I can simplify the right-hand side by multiplying 0.8 and 0.85. I get 0.68 times the list price. Now to isolate list price, it's being multiplied by 0.68. So I need to do the opposite and divide both sides by 0.68. And we can see the 0.68s on the left-hand side cancel each other out. I have list price is 765 divided by 0.68, or 1,125. And if Ski West uses 1,125 as their list price with their 20% and 10% discounts, they are going to have a lower net price than the competitor. In fact, their net price is going to become $765. And I've just got one little slide that you can read. It's a little cartoon that talks about trade discounts. As you can see that they are negotiating how they can get a reduced price if they get 50 boxes instead of just one. And then towards the end, they're talking about payment terms. And that's what we're going to talk about in lecture 4, some payment terms.